guys have a note sheet? Okay, where are we here? 37. So this is actually the last note sheet before your test. If yours says the 13 up here, can you change that to a 12? Although, honestly, it'll probably take us both class periods, so it might not be totally wrong. Notice here we have two normal distributions, right? One is solid and one is dotted. What you're looking at, both of them have the mean at 0, but what's happening is your standard deviation is different for both of them. So if your mean is at 0 and you have a standard deviation of 1, it's going to be much more tall and narrow than if you have a standard deviation of 2, because from here you'd have to go out 2 and then go out 2 more. Here, the standard deviations are the same. See how they're keeping that same shape, but the mean has changed. So just kind of two different ways of looking at it. A normal distribution is always in that bell curve. This is a little bit of a review. It has symmetry, so it's symmetric around the mean, median, mode. The mean and the median of the normal distribution are both equal to the mode. And it follows the empirical rule, which you guys remember these percentiles, right? One standard deviation away from the mean is 68% of your data, 2 is 95%, and 3 is 99.7. Area under the normal curve, normal distribution can have any mean and any positive standard deviation. The distribution of the mean of 0 and a standard deviation of 1 is known as the standard normal distribution. Remember, that's when we calculate that z-score. So anytime you hear z-score, think 0 and 1. 0 for the mean, 1 for the standard deviation. When finding the area under the standard normal curve, we use z to indicate the value on the horizontal axis beneath the curve. Finding the area under the normal curve with the TI 84 plus, really any of the 84s, is normal CDF. So if you're looking here and you're trying to find the area under this curve, it's referred to as area, which says that there, but it's also proportion, probability, and p-value. They're all talking about the exact same thing. Now, the nice part about the normal CDF is opposed to the binomial CDF and PDF, or CDF. Binomial, you had to do less than or equal to. Normal, you don't. So you don't have to worry about like doing the 1 minus and all that stuff. The calculator does it for you. And remember, normal curve is a continuous function, so you don't have to worry about it being just all the discrete separate numbers. This one's all the numbers underneath. Okay, find the area under the curve to the left of z equals 1.26. So when you see z, that means that this one is 0. And these are counting by 1. So 1.26 would be like right here. And this would be negative infinity down yonder way. Okay, if you are using your little bit older versions of the calculator, I'm just looking to see what you guys have. We're going to use normal CDF. Which is under that second bars, excuse me. The first number you're going to type in is your lower bound. Now, the newer calculators are going to prompt you for this, so you don't really have to worry about it if you have a newer calculator. Lower bound, comma, upper bound. The mean, and then the standard deviation. And this is going to give you your p-value. Is that command. P-value, which is also the probability, which is also the proportion, which is also the area. But again, if you have a newer calculator, you don't have to worry so much about knowing what order these come in. So if we're looking at this, find the area to the left of a z-score of 1.26. So you're looking for the area of this shaded region. You would say, okay, well, that's p-value equals. Where does the normal CDF. The shading begins at, you read it like you do a book from left to right. So negative infinity. The shading ends at 1.26. And because this was a z-score, we know the mean is 1 and the mean is 0 and the standard deviation is 1. So 0, 1. So check out your calculators. Go to your second bars, normal CDF. Normal CDF is right here at number 2. Hit enter, and right here you're going to be able to tell if you have a newer or older version. Now, this defaults to this -1E99. That's this negative infinity, basically. It's in scientific notation. If you have an older calculator, just put like -1,000,000 or something. Because if, even when you're talking about z-score, 99.7% of your data is going to fall between -3 and +3, so using -1,000,000 here would be pretty apropos. And it defaults to a z-score. Now, if you're not using a z-score, you're going to change those numbers, but our upper bound is 1.26. Enter. And that's your p-value. And again, round to 4 decimal places, so... .8962. Okay, find the area to the right of -5. Now, again, z-score, your mean is at 0, so the negative is going to be over here. So we'll put it like here. -0.58. So p-value equals normal CDF Now this time, the shading on the low end of this is -0.58. And now it's going to infinity. It's a z-score, so mean is 0, standard deviation is 1. So go ahead and calculate that. Is anybody having troubles with finding that or using? Sometimes don't put in I don't know, million or whatever. All right, questions on that? Again, what we're finding is the area under that curve, which the whole entire area would be 1 unit. Hey, this is Cindy. Hey, this is Cindy. Thanks. I do. I will. Okay. You're welcome. Bye. You need to leave it at 8:40 and to sign out in the office. Okay. So here we go. Find the area between z equals a negative 1.54. So that's going to be like here, right? I said 5.4, negative 1.45. That's what the problem actually says. And z equals 0.42. Again, your p-value equals normal CDF Now the low end of our shading is at negative 1.45. Our high end is at 0.42. Mean is 0, standard deviation is 1. Any questions on these? And your area will be 0.5892. Okay, so this is what you do when you want to find the area under the curve, or if they said, what's the probability that the number falls between here and here? Again, same process, or what's the proportion of the data that falls between whatever region. All that stuff is finding your normal CDF, finding that area. If you're given the area, you're going to use inverse norm. Given the area. And looking for z-score for x value. Okay, so you're going to use inverse norm. Notice how they're right together when you're trying to find, when you're given the area and you're looking for one of the values down here. Now, find the z-score. Now, right away, they say z-score, so we know that the mean is 0, standard deviation is 1, that has an area of 0.26 to its left. So 26% of the area is to its left. So that's going to be down here somewhere, isn't it? Just do a little estimate. God bless you. That region right here means that the area here is 0.26. So what little score right here, what z value has 26% of the data to its left? Well, you would say z equals inverse norm. Now, on your calculators, go ahead and look at that real quick. It asks you for the area. Now, this is where it's a little tricky with the newer and older. The older ones won't have that left, center, right. If you have that, use it. It becomes a little bit, they don't use it the whole time, which is unfortunate. So you're almost better off like learning how to do it with the older calculator, but either way, the default is to the left, and this problem's to the left, so it's really not a problem. But we have 26%, 0.26, mean of 0, standard deviation of 1, the shading is to the left, and so enter. So let me jot that down. Oh, okay. So if you're on an older calculator, you're gonna hit inverse norm. Then you're gonna write down your area that you're working with, your comma your mean, comma your standard deviation, and then hit enter. Did that work? You should get z equals negative 0.6433. Is that what you got, Keith? All right. This is, and I'm going to try to show you them both ways, depending on if you have a newer or an older calculator. And there's like different phases of the calculator. Like Hayden's calculator didn't have any of this. Like it didn't have the menu at all. And then some of them, like the next version of it, had the menu, but it didn't have the left, center, right. And then now they have the left, center, right. So it's all like where you happen to be. Okay, so find the z-score that has an area of 0.68 to its right. Okay, so z-score means this is going to be 0. You have 68% of the data to the right of it. Well, let me just put a little dotted line. The area to the right of the mean, what percent of our data is there? Like that I just shaded in. 50%, right? So 68% is going to fall over here somewhere. Okay. People with the older version, we know that this that we shaded was 0.68. If you are defaulting to the left, how much of the data would fall over here? How much is unshaded? 0.32, right? So, if you don't have the left, center, right, when you type this in, you're going to have to find defaulting to the left. You're going to have to find the z-score down here. And you'll know if you're right or wrong because you know the z-score where it sits right now has to be negative. So, older version, you're doing inverse norm, 0.32, 0, and 1. Newer version, inverse norm, 0.68, 0, 1, right. But either way, you should end up with a z-score at, and you guys do it to verify that it works, negative 0.4677, or that I'm giving you the right answer. Cool. Okay, find the z-score that bounds the middle 95%. All right, so we're saying this is 0.95. The z-score is going to have to be z-scores, right? We're going to have a z here that we know is going to be negative and a z right here, which is going to be positive. But they're symmetrical, so they're going to have the same absolute value. So it'll be like plus or minus 2, plus or minus 1.9, whatever, something. These will be the same. If you have an older, if you have an older version, what percent of the data, what's the area from here to here? Yes, so 0.025, because it's 2.5. If we know the middle is 95%, that means there are 5% left for each of these unshaded, 2.5 each. We know that this, if we're following it over, would be 0.975. And we use that a lot, that shading it all the way over. So when you're typing it in here, you can use either of these two numbers. It does not matter. If you have a newer calculator, you're going to do, oh, what am I writing? Norm inverse? No, inverse norm. .9501 center. Either way, this one's going to give you a positive z-score. This one's going to give you both. But either way, you have to acknowledge that both of them are true. So your z-score is negative 1.96 and positive 1.96. So if you just get one of them, you have to show that there's actually both of them. Questions on that? Okay, let alpha be a number that's between 0 and 1. The notation z sub, I'll probably have to write this bigger, alpha over 2. Let me write that over here. Z sub alpha over 2 refers to the z-score with the area to its right. You need to use the complement when finding the right side. So let's shade here. Z sub 0.2 would be that last 20% over here with an area 0.2. And again, it's the exact same thing. So Z sub alpha over 2 would, in this case, be Z sub 0.8. If this is 20%, this means this is 80% or 0.8. 0.801. A z-score with a particular percentage of area to its left is called percentile. Okay, and we did this already, going back through it. The z-score of x is found with that formula, z equals x minus mu divided by sigma. For the population, it would be x bar and s if it was for a sample. The height of a certain population of women follow a normal distribution with a mean of 64 inches, standard deviation of 3 inches. A randomly selected woman has a height of x equals 67 inches. Find and interpret the z-score for this value. The z-score for 67 would be 67, that's your x value, minus the mean is 64, divided by the standard deviation, which is 3. Because z is positive, we interpret this by saying that the height of 67 inches is 1 standard deviation above the mean. Sorry. 67 minus 64 is 3, divided by 3 is 1. I'm going to push pause on this for a second. And I want you